Hello, good day viewers. In this tutorial, we are going to talk about absolute value inequalities. But before we dive into the inequality, let us talk about the absolute value. Can you remember absolute value? If you have negative 2, in an absolute value, it will always be equal to positive 2 because the absolute value will transform the number to positive. Likewise, if the number is positive, it will remain positive. This implies that the absolute value of negative 2 is equal to the absolute value of 2. So what is this all about? It means that the absolute value of any number is the distance of that number from origin, 0. Take for instance, if we have a number line here, we have origin, which is 0. If we place 2 right here and we have negative 2 right here, use any measuring instrument, you will have the same distance from origin. The distance from 0 to negative 2 is equal to the distance from 0 to positive 2. They have equal distance. So the absolute value is nothing but the distance of that number from origin, right? So what if we have an absolute value of x, for which x is just representing a number? This means that from origin, we could have x to the right and negative x to the left. But make sure they have what? Equal distance from origin. This means that absolute value of x could either be x or negative x. Under a condition, it is positive x if and only if x is greater or equal to 0. Because you can see that all these values to the right hand side of 0 are all greater or equal to 0. And it can be negative x if x values are less than 0. You can see that all these values towards negative x are all less than 0, right? So this is how you can represent an absolute value of x piecewise. So now let us introduce inequality. If we have an absolute value of x, we already know what it means. Let's assume it is less than 2. What does this mean? It means that the distance of x, which is a number away from 0, is less than 2 and always less than 2, strictly less than 2. So let us plug it on a number line and see. If we have a number line here, this is the origin. It means that the distance must be less than 2. We have seen that in an absolute value, you have to introduce both the negative and the positive numbers. So we have negative 2 here. I remember every single negative number you plug into the absolute value, it will be transformed to a positive number, right? So we have negative 1 here, we could have 1 right here. So what are the numbers less than 2? If you move to the right hand side of 0, we could have 1, 1.1, 1.2, up to a number very close to 2, but it will never reach 2. Because all the numbers closer to 2 towards the left hand side are all less than 2. But suppose we have less than or equal to, you have to include 2, right? At the same time, if you move towards the left hand side of 0, all the negative numbers in an absolute form will be less than 2, numbers very close to negative 2. This means that this x, this particular x, can be what? Less than 2. If you move towards the right hand side, you can see all these values of x must be less than 2. As well as x greater than negative 2, right? Because remember that all values to the right hand side on number line must be greater than the number towards the left hand side. So if you consider negative 2 here, all the values to the right hand side of negative 2 must be greater than negative 2. So you can clearly see that the solution is from what? Negative 2 down to positive 2, which you can write like this. Negative 2 less than x less than positive 2. Or in an interval notation, as x belongs to the set of values from negative 2 way down to positive 2. Let's take another example. Suppose we have x plus 2 in an absolute form, maybe greater than 4 this time around. It means that the distance of x plus 2 away from origin is greater than 4. So let me give you an instance. If we have a number line like this is origin, we have 4 here, and we have a negative 4 right here. Remember that we could have 5, 6 in that order to the right, and we could have negative 5, we have negative 6 in that order. So let us analyze this. We need all those numbers that are greater than 4. You know that they are going to be 5, 6, 7, and if you move to the left, we could have negative 5 because we are going to take their absolute value, right? Remember, we are talking about distance. So we have our solution from this end and what? This end. Any number you take to the left hand side here, take it absolute value, it will be greater than 4. If you take absolute value of negative 5, it will be 5, and 5 is greater than 4. Take absolute value of negative 6, it will be positive 6, and it will be greater than 4. And these are already positive without taking their absolute value. They must all be greater than 4. So what will be the solution? Just take a look. Naturally, we know that all these values must be what? Less than negative 4. So it means that x plus 2, which is under the absolute value here, can either be less than negative 4, or that value x plus 2 be greater than 4. So if you look at this one, all values to the right hand side are greater than 4, but this ones, they are all what? Less than negative 4. So this is how to interpret it. So we solve them separately. Taking this one to the other side, it becomes negative. So we have x less than negative 4, negative 2 is negative 6. And we have taking this one to the other side, it becomes negative 4 minus 2 is 2. So we have x greater than 2. So on the number line, we can represent this information. This is 0, this is negative 6, and this is positive 2. So we are talking about where x is greater than 2. You see that here? Where x is less than negative 6, we have it right here. So you see, this is our solution on the number line, and you can write it in an interval notation as, because remember that as you move towards the left hand side, it is approaching negative infinity. So x belongs to the set of values from negative infinity. They will all satisfy down to negative 6. Union, because we have no solution here, we take 2 down to positive infinity. So this is just the solution to this problem, and this is what in an inequality form. Though you cannot join them together because there is no intersection, right? So this is basically an introduction to the inequality. So if you don't want to use number line, let me show you how you can always interpret it. For example, this absolute value of x plus 2 greater than 4, let's use it as an example. Absolute value of x plus 2 greater than 4. We know that the value under the absolute value is either positive or negative. It is the absolute value that will always transform it to positive, right? So we assume two cases. It could be x plus 2 greater than 4, or negative x plus 2 greater than 4. This is how to interpret it, because it could be negative or positive. So we solve them separately. Taking 2 to the other side, it becomes negative. We have x greater than 4 minus 2 is 2. Then you come to the other side, you divide both sides by this negative, divide both sides by negative 1, such that this will cancel this. So we have x plus 2. But the direction of the inequality will change. Remember, if you multiply or divide both sides of an inequality by a negative value, the direction of the inequality will change from greater than to less than type. Then 4 divided by negative 1 is negative 4. So this is where we have these two conditions. Remember, this is the condition. x plus 2 less than negative 4. Then you solve. Taking this one to the other side, it becomes negative. We have x less than negative 4, negative 2 is negative 6. So this is where we have these two solutions. So subsequently, we're going to solve a lot of problems. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.